Hi everyone, thanks for joining today's webinar. Today's webinar is titled Full Life Cycle Container Security that Matches the Speed of DevOps. Today's date is May 15th, 2019. We're doing this webinar live and it will be available for playback, and a link to the recording will be sent out for those who have registered for this webinar and may not have been able to make it. My name is Kyle Klassen. I'm on the Trend Micro Deep Security Product Management team, and I have responsibility for container security, among other things. And joining me today is Jeff Basquill. He's the development lead for SmartCheck, which is one of our key container security components that you're going to learn about today. Couple of housekeeping items. So there is a Q&A tool, so you can submit questions. And while I'm speaking, Jeff's going to try to answer some, and then while he's going, I'm going to try to answer questions, and we'll end the session with going through some of the Q&As that we think everyone could benefit from. And as far as the agenda goes, there's kind of two parts to this webinar. So I'm going to kick it off with the first section, and that'll take me probably about half an hour. I'm going to give you a walkthrough and introduction of Trend Micro's container security solution. And then for about 15 minutes, Jeff is going to run through a demo, and he's going to show in detail how to integrate SmartCheck into your Jenkins pipeline and to automate some of the scanning capabilities of SmartCheck. So that's very interesting for those of you who are looking for some hands-on guidance, and if I'm boring you in the first half hour, stick around for that, please. Okay, so starting at the top, so how does Trend Micro help in DevOps? Well, we like to tell customers we help build secure, ship fast, and run anywhere. So by building secure, we mean that we offer a range of tools and capabilities to help you meet your security and compliance requirements, starting right at the first build of your images. We allow you to ship fast, which really means that our tools and security capabilities are designed for fully automated integration into your CI/CD pipeline, so that you don't have security roadblocks along the way. You can integrate security into your existing processes and tool sets so that it's frictionless, and you can deliver quickly and increase speed. And then running anywhere. So for the runtime protection, the deep security runtime agent is actually the #1 cloud workload protection agent deployed out there. We support all of the cloud platform vendors, and so we allow you to, once you've built your secure image and you want to protect that image from attacks in runtime, you can ship and run it anywhere. So build secure, ship fast, and run anywhere. So what I'm showing here is a simple pipeline model. So our container solution is a full lifecycle security offer. So that means that we do have security capability that is relevant right from the time you build your Docker image, as well as it proceeds through your pipeline, stored in the registry, and then also is promoted and deployed out into your runtime environment. So I'm going to use this very simple pipeline model here, which shows a developer who's made a code change, submits that code change to GitHub, for example, and the pipeline tooling would create a build. So that might be GitLab or Jenkins, what have you. That image is built and then pushed to a registry, and then subsequently your orchestration tools would pull that image when appropriate out into the runtime environment. Of course, your pipeline is probably a little more complicated than this, but this is a very simple framework for purposes of introducing the solution. I'm going to start with the runtime. So looking at runtime attack risks, we'll start with this stack. So the model here is a very simple multi-layer stack. You've got an operating system in the bottom. On top of it, you've got a Kubernetes orchestration layer, which is pretty much the de facto standard out there for orchestration. You also have a Docker runtime engine, and then on top of that, you've got your running container applications. So this is sort of representative of the runtime environment. And when thinking about risks in your runtime environment, you need to, of course, consider attacks on the running applications themselves. So things like, SQL injection or cross-site scripting, exploits on any vulnerabilities that might exist, denial of service attacks, et cetera. Looking elsewhere in the stack, so down at the OS layer, so of course, very important foundationally to have protection for the OS layer, both against exploits and vulnerabilities and protection against weak configurations and those type of things. Very important in the container environment with a shared kernel. As we saw recently with the runc outbreak, if there is a compromised container, there is the potential for infecting across other containers because there is a shared kernel. So very important to have strong OS layer protection in your security model as well. And then also attacks against the container platforms. So this is kind of something new in the container environment because you got the Kubernetes and Docker layers. You want to make sure that in runtime you've got suitable protection in place to block against attacks that might be looking for avenues via those platforms. So protecting in the runtime environment, in our portfolio we've got the Deep Security Agent, and it provides protection on the for all of these layers, which I'll go through in a little more detail. The agent itself, as I mentioned, it is the most widely deployed agent protecting cloud workloads. It does provide visibility into the compute environment, which is very much appreciated by customers. So regardless of whether you're using Google or Amazon or Azure, the agent will provide you with complete visibility into the status of the workloads. And if they're running Docker and containers, and provide you with the relevant telemetry and data. The agent does provide deep packet inspection of all network traffic, and the agent does see north, south, and east-west traffic between the containers themselves, so even on the same node. So we have complete visibility to all the traffic that's going in and out of each individual container. We do provide real-time monitoring of all the container activity. So we hook into the Docker socket, and we watch all the container activity. We monitor all the file system activity on the platform, look at all the system calls, inspect all the running processes and their behaviors. And we even look at system and application logs as well. So there's a lot of security information that may be buried, or security relevant information that's buried in noisy logs generated by components on the platform. So we look at all that as well to detect and provide protection measures if an attack is detected. And we do have advanced detection techniques embedded in the agent as well. So we look for anomalies versus the expected behavior. We've got heuristic models, which are basically sort of rules of thumb, so we know that what are the expected behaviors of various components, and we look for deviations from that. We have advanced machine learning algorithms as well embedded to look for certain types of attacks and certain types of malware. And then because the agent is deployed on the host, we do have very specific application context, so we can be very finely tuned for the detection and protection on that particular host, so that we can minimize false positives and maximize security. So deploying the agent onto the host, there are two ways to do it. The way it's been done for a long time is to deploy at the OS level and install a software. You install one agent per host, and we've got a number of ways to automate deployment. So we've got deployment scripts that are generated by the system and can be used by Chef, Puppet, or Ansible, whatever have you that you might be used to deploy the workload and automate the deployment of the agent. The agent does automatically reach out to a manager to get updated patterns, updated policy, and so on. So you can apply a common policy and common management in a multi-cloud environment and hybrid cloud environment, including your own private data centers, for example. All right, and newly introduced, so currently in customer preview, we do have a version of the Deep Security Agent that's designed to be deployed as a container. So for some customers who wanted to just have a single Kubernetes pipeline to deploy all of their applications out into their cloud services or out into their managed Kubernetes clusters or private Kubernetes clusters. They just wanted to have the agent deployed as a Kubernetes application. So that's what we're doing with Deep Security Agent for Kubernetes. So it runs as a container, one agent per node, and it deploys as a Kubernetes Helm chart, just like any other of your Kubernetes applications. So there are two ways to deploy the agent. Okay, once the agent's deployed, so getting into some specifics of the type of protection we provide in the runtime environment, looking at the bottom part of the stack, the OS, the Kubernetes and Docker space, we have a full gamut of security controls that have been built into the agent over time. So that includes anti-malware, which is to look for malicious files, web reputation, so we detect any connections out to malicious or CNC servers. Firewall, which can be used to control traffic in and out of the host, so you can minimize the attack surface. Intrusion prevention, so we've got a wide range of rules to protect against attacks at all layers in the stack here. Integrity monitoring, which basically provides insurance against or detection of any changes against a baseline model, so you can detect any changes, and if they're unexpected, then it might be an indicator of attack. Log inspection, as I mentioned, we actually look through logs with a security lens to find indicators of attack. And then application control, which is basically whitelisting of known good applications, so you can lock down servers and only allow good applications to run. So very comprehensive set of security capabilities here, and we always endorse as a best practice to have a multi-layered security approach. Now, with the containers themselves, due to some of the isolation, the controls that do apply, we've got real-time anti-malware scanning. So for any of the applications running the container, any of their activity that writes to disk, we will detect and scan for malware. And then also intrusion prevention. So all of our IPS rules we do monitor all the traffic north, south, and east, west. So our IPS rules can be applied at the container level. And then looking at the Kubernetes and Docker layers, so very important, on some of the attacks that we've seen over the last couple of years, there have been a number that have targeted Docker and Kubernetes, both with targeting vulnerabilities and or weak configurations. And so we do have capability in the Deep Security Agent, some specific logic and detection capability to monitor Kubernetes and Docker themselves. So we actually look and monitor for the software versions and monitor for any software changes, upgrades, downgrades, or removals, for example, any changes to the attributes of key binaries. We monitor running processes, critical files, so system files, configuration files, certificates, and so on. We monitor for unexpected IP tables, rules, changes, also permissions on key directories, and then also the logs generated by Docker and Kubernetes. So all of this is monitored, and we have detection rules that are triggered if we're detecting an incidence of attack. So this ensures that you're mitigating an attack vector that might be looking to come in via Docker or Kubernetes. So in summary, looking at the runtime environment here, our protection does cover the OS layer, Kubernetes, Docker itself with very specific rules and monitoring capability, and then extend the real-time malware scanning and intrusion protection up to the container applications themselves. And so with this, all this capability combined is what we call the full stack protection. So at runtime, we really lock down the container host so that there's maximum security in the runtime environment. So that's kind of a high-level view of what we're doing at runtime. Now back to our model here, and in the spirit of providing a full container lifecycle solution, we'll take a look at what we're doing for the pipeline, so the earlier stages when the image is being built. So the key component in the deep security portfolio addressing this requirement is called Deep Security Smart Check. And the spirit of Smart Check is really to move a lot of that detection capability plus other capability basically left upstream so that you can provide early detection of any security issues relating to the image. Deep Security Smart Check does deploy as a Kubernetes application. It's designed to be run as a service and basically integrates seamlessly into your CI/CD pipeline, and that's what Jeff will be showing in a few minutes, using the comprehensive set of APIs that are supported in the product. So let's talk a little bit about pipeline risks. Because the runtime environment is locked down, especially protected with an agent like Deep Security, the reality is that a lot of the risk comes by way of software changes that are introduced into that environment. Those software changes are typically coming from a continuous stream of updates from the CI/CD pipeline. So, there's a number of ways that unknown and potentially malicious code or problems can make its way into your images. So we know that developers are very creative and will look to reuse and as many components as possible. So there are public repos out there that have vast resource of components that can be used to assemble applications. Sometimes there's old code that is trusted, can be reused. Sometimes packages themselves will pull in dependent libraries and so on that will introduce unknown components. We do have a customer that was just asking this week because in their pipeline they actually have feeds from a lot of third-party contributors, and they wanted a means to make sure that what they're packing into their image is actually clean. And then there are a chance for misconfiguration. So despite the best intentions, developers might forget some things, might try to deploy an image that's got some poor configurations, or they might leave some credentials or other information embedded in the image, which should not be made available when that moves out into the runtime environment. So all these sources can lead to problems if images are built and not scanned and not cleaned, and then they're moved out to the runtime environment. So you might have vulnerable code which can be exploited. There might be vulnerable configurations which will provide openings for an attack vector. There might be malware that can execute. And you might have secrets, keys, certificates, and so on that are exposed that can be retrieved and then used as part of some other attack campaign. So it's very important that the images are scanned. And so what SmartCheck does is provide a very comprehensive scan service for your images. And so in again, the simple diagram here, we've got at the build stage, one of the things we recommend for customers is that as soon as the image is built, that the image is scanned. And you can do this before it's pushed to the registry. You'd want to do this because you'd want to minimize the chance that this image is being pulled and reused by others, for example. So ideally, you want to make sure that your images are clean before they're pushed to the registry. So SmartCheck does have multiple scan capabilities. So SmartCheck does look for vulnerabilities. SmartCheck will scan and detect malware. We'll look for secrets and keys and PEMs and certificates. And we'll also look for certain configurations and validate them against compliance standards and give you a report in a checklist format. And then also you can create your own custom rules and have that as part of your scan and result criteria. So a good use case that some customers are using is to look for IOCs. So if through your threat intelligence you might have a particular IOC of interest, some hash value and so on, you can simply, create a custom rule to look for this anywhere in your pipeline. And it's good practice as well to not just scan your runtime environment, but also software that's in your pipeline that imminently will be pulled out into runtime. So you want to make sure your IOC sweeping, for example, includes the pipeline, and you can do that with Smart Check. Okay, so once the image is built and scanned, just a note on vulnerability detection first. So when looking for vulnerabilities, in the early stages of the development of Smart Check, and as part of our benchmarking against other scan engines, we were surprised to find some of the limitations that are out there in scanners that are widely used. So typical, if you think about how software is deployed, you have a couple of ways. So most software is deployed using package manager, and so you can look at the package manager to see which packages do exist in the image. However, there are also many packages that are installed from source or downloaded and extracted, and can be installed that way. Some of them can only be installed that way. So a lot of the scanners, to our surprise, would only look at what's been installed via the package manager, which means it's blind to other important applications. So things like WordPress or Drupal are a couple of good examples that are commonly installed, are downloaded and extracted, so they're missed by these scanners. So Smart Check does have specific intelligence to detect the presence of these other applications, so that our vulnerability detection does provide full coverage and isn't blind to those that have been installed by other means. So very important to have comprehensive vulnerability detection. Another consideration are some of the embedded dependencies, so some of the application library components, for example, and you want to make sure that the scanner does have appropriate coverage for these components as well. Otherwise, there could be a risk that some of the packages are harboring vulnerabilities that you're not aware of and might be missed by other scanners. So that's on vulnerability detection. Then back to our pipeline model. After the image is built and pushed to the registry, we do recommend that you continuously scan the images in the registry. And the reason you want to do this is because if an image is scanned and determined to be clean at time zero, that doesn't mean that it will still be clean a week later, 2 weeks later, because there are always new vulnerabilities that are discovered. There's new malware that's discovered and so on. And even compliance might creep a little bit as well. So for all these reasons, you want to do continuous scanning of the images. In an ideal world, or these images might be very short-lived. Practically speaking, we're finding a lot of customers are dealing with images that have very long duration, and they they're in the registry for a long time. And so the longer they exist, the more likely that there will be new vulnerabilities that apply to those images. So you want to also continually scan the registry. Smart Check does benefit from Trend Micro's global threat research team. So we do have a core competency in threat research and threat intelligence. So we actually have 400 dedicated employees in this area, 14 locations around the world. And the pie chart there shows, I think this is last year's stats for zero-day discovery. We're actually the number one globally for discovering 0 days. So this group provides all of the early insight, all of the patterns, all of the detection rules that are fed to Trend Micro components, including Smart Check. So Smart Check's updated regularly with this new threat intelligence and patterns. And so you want to make sure that your repeat scans always use the latest threat intelligence. And so we're a leader in this space. And good practice to continually scan in the registry, and then also, of course, scan when the image is first built. Okay, so once an image is scanned, I'm showing here the dashboard view of Smart Check, which has some pretty graphics. You can see the state of your scans if they're complete, and then each a view of each of the different scan types. So malware, content findings, which are the secrets and keys, vulnerabilities, and then also compliance. So compliance is in form of a checklist. So we support HIPAA, PCI, and NIST today, and we'll be expanding over time. You can create different views based on which registry, which repository, which type of images you're interested in, create unique views, restrict access to those views by role or individual. And on the right-hand side, just showing kind of a click-through view of an image scan results, so you can see all the layers and which layers have issues, and if you can click through, then you will see details on those issues. So this is great for users in roles where you want to go in and kind of get a high-level view of what's going on. But more likely when integrating in the CI/CD processes and workflow, you likely run SmartCheck as a service and use the APIs. So we got a full suite of APIs supported in the product, and in fact, there's much more functionality available via the APIs than we actually reveal in the user interface. So there's been a lot of attention at this part of the product. All of the APIs are well documented, well described, including code samples, so you can copy paste and get going early. So the deployment model is pretty simple. So SmartCheck deploys, as I mentioned, as a Kubernetes application designed to be deployed as a service. Use the APIs, integrate with your pipeline tooling, and create a scan task at build time, and then configure to continuously scan your registry. And basically, SmartCheck will receive scan requests, run the scans, and return scan results. So it's pretty simple deployment model, and you can build this integrated into your pipeline so that you've got a seamlessly integrated security check and allow you to detect issues as early as possible. All of the results, of course, are available by the API as well, so you can get feedback directly to developers if issues are found. All of the results will show exactly where the issue is, what it is, and links to any fixes if available. Developer would use that information to fix the image, add the updates, whatever it needs, resubmit the updated image, and it would presumably scan clean and then be allowed to proceed through the pipeline. And then, admission control. So SmartCheck can be used to consult for admission control. So at the final stage, you can ask for a scan result and make sure that it complies with your policy to deploy out into the runtime environment. So you can do that either with a task in your pipeline tooling, or you can integrate with Kubernetes. And for customers who are using the Deep Security Agent out to protect the workloads at runtime, you will be able to use this admission control embedded in the Deep Security Agent itself as an option. So at this point, I'm going to turn it over to Jeff, who's going to, he's a master at mitigating risk, so it's going to be run as a media clip. He is in the room here right beside me, but it's about 13 minutes. He's going to show an integration of SmartCheck with your Jenkins pipeline, and then we'll be right back. And so we'll look for questions in the Q&A tool and handle those right now as well. Okay, over to Jeff.
Hi, I'm Jeff. I work on Deep Security SmartCheck. And today what we're going to do is walk through a sample pipeline and how to integrate Deep Security SmartCheck into it. Today we're going to be using Jenkins, and we'll walk through all the steps that you need to do, and hopefully you'll find it's pretty easy. So before we get started though, let's take a look at what the pipeline looks like. So what you can see here is a simple, very simplified pipeline where you start on the left with code that gets built into an image, that gets scanned by Deep Security SmartCheck, And then the scanned image, if it's fine, if there's nothing wrong with it, then it would get pushed into a production registry and moved into production. It would get deployed in production and it'd run. If Deep Security Smart Check finds any problems with it, then we would investigate the issues and remediate them. If there's malware, for example, you'd obviously track down how the malware got into your image, clean it out, and get everything worked out. If there's vulnerabilities in place, then you'd work on mitigations using something like Deep Security to protect your service when it's deployed into production, or if there's any content that shouldn't be in there, like a private key that's been included in your image, or an API key or something like that, then you would obviously again clean that up and make sure it didn't get into production where it could be compromised, or if there's any checklist findings. So if you have a PCI DSS or HIPAA requirements that when we scan for compliance with those checklists, you could remediate those problems and again rescan and then get your image out into production. So that's the basic structure that we've got here. And what we're going to do is switch over now to Jenkins, where I have set up a sort of a mirror of that pipeline. It's really simple. Again, starting on the left with pulling the source, building the image, testing the image. Kind of added that one in here just to show you that test phase. Then pushing the image into a registry and deploying it out to production. You can see we don't have Smart Check in here yet, and that's what we're going to walk through right now. So let's get to it. So we're going to go in here and configure the pipeline job. So if you're not super familiar with Jenkins, this is one of the ways that you can configure a job or a pipeline in Jenkins. And so you can see we have the different stages that we talked about before. So you'd pull the source, building the image, testing the image, pushing the image, deploying it, right? So very simple. A lot of people will have much more complicated pipelines. We're trying to keep it minimal for the purposes of this demonstration. So what we're going to do is we're going to add the scanning to the test phase, right? So we can do our tests and our scans at the same time, sort of keep things parallel, so that if your test takes a long time, then you can get your scans done really quick while the tests are running. So I'm just going to go over here and I'm going to grab the scan block and I'm going to drop it in here and we're going to talk through it. So what I've got here in this scan image block is all you need to do to set up the Smart Check scan with actually pre-registry scanning. And what pre-registry scanning is it's scanning the image before it's actually been pushed to any registry. So what we do is we run a registry inside the Smart Check cluster, and you can push the image to there, and that way it's not in your production registry where it could be accidentally deployed before it's been scanned. So we just make sure that that we're scanning it before it gets into the registry. And so you can see that we just call this Smart Check scan function, and that's actually provided by our Jenkins plugin that we're going to install in a second. We provide it with the name of the image that we just built that we want to scan. We tell it where the Smart Check host is, and we provide it credentials for the Smart Check host. We tell it that we want to scan prior to being in the registry. This isn't a required thing, but a lot of people want to do it before they push their image. And then sort of at the end there is, because I'm running this in a demo environment, I'm kind of skipping the certificate validation. You would not do this in production. So we're going to save that. And next thing we're going to do is we're going to go back and configure Jenkins. We're going to add in the Smart Check plugin. So you go into the Manage Jenkins and then Manage Plugins under there. And you will find, if you go to the available plugins, and filter for deep security. And we've put the Deep Security Smart Check plugin into the Jenkins Marketplace so that you can just get it, and it should just be right there. So check the checkbox to install it. You don't need to restart to install the plugin. It'll just work, and it is already installed. So good to go. One thing I want to make sure of is that those credentials that I mentioned, I want to make sure that I've created them, and I haven't actually created them here. So when you've got Deep Security Smart Check and the registry, we need to make sure that we've got the right credentials for our build to be able to access them, actually. So we're just going to add those here, and I called it Smart Check Auth, and it is the Deep Security Smart Check API credentials. Okay. And we also had the registry credentials too, so I'm going to add those. And it is called pre-registry auth. Deep Security Smart Check Registry credentials. And Jenkins has some really great things for restricting what jobs have access to credentials and stuff. I'm going to let you do that as an exercise. We're just going to have simple credentials here, but everything would work as you would expect it to. So we added the plugin into the job a second ago, and we've got our credentials created, and let's run the build. So that's going, and let's switch over to the Blue Ocean view because it's a little nicer to look at. You can see the build is running. We've already pulled our source, we've built the image, and now we're scanning and testing the image in parallel. Right, so both things are happening. Let's take a look at the details. So you can see we've done the Docker login, so this has been pushing the image into SmartCheck, and we're doing a scan. And so what the scan is doing is it's looking for malware, it's looking for vulnerabilities in any of the packages that you've got installed in your image. It's looking for any files that are in your image that shouldn't be, like API keys or private keys or anything like that. And it's looking for checklist compliance. So for some image types, we will check for PCI or HIPAA or the NIST checklist. And actually we found a bunch of things, so why don't we, and you can see that, let's see, there we go. So Jenkins has failed the build, failed the pipeline, so we're not going to deploy this image because the scan has failed. And why don't we take a look at the details here. So you can kind of see not a lot of detail here, but if you go to the classic view, there is a Deep Security Smart Check Scan report. And in the Deep Security Smart Check Scan report, which I'll click on now, you can see a little more detail. It's really just some metrics around what it's found. It's found some malware, it found some content findings that seems to be high severity, some vulnerabilities, again, high severity, some medium, and then some checklist findings as well. It doesn't have the details here, but for more details, see the full scan results. So let's pop into Deep Security Smart Check to see those. And so we've logged into Smart Check, and you can see here the image. And again, we've kind of got the high-level summary of everything that's been found. And you can drill down into the individual layers to see what's going on. So for this, for example, this first layer seems to have some vulnerabilities in Apache. So we've got Apache 2, we've got some high vulnerabilities there, and we can click here to see the details, some high, medium, and unknown. Looks like all of these could be fixed, right? So there's a fix available in a newer version. So if we upgraded Apache, then we would have fixes for those. We've got some malware here. So we've got iCar. Okay, so iCar is a test malware image, or that we've included in this sort of for demo purposes. So I'm not super afraid that this has been exfiltrating my data to who knows where, or doing some ransomware on my code. But just sort of so you can see the malware is picked up here. In this layer, we've got some content findings. So we've got a private key, just an unencrypted private key that's been found, and we can see where it was. It was in this private unencrypted.pem, and actually that's listed here as well. And then here we've got actually more vulnerabilities. So a bunch of stuff with Python and OpenSSL. We can go through the checklists, and you can see the different checklists that we go through. So PCI DSS, we've got a bunch of checklist items there. Then NIST 800-190 compliance, a small checklist there, and HIPAA as well. So a bunch of different checklists that you can go through and see all the different results for your images. And let's see, one last thing I want to show you in here is the dashboard, so you can kind of see sort of at a glance what's going on with your system. You can see all our images have been scanned. We found one piece of malware, got some content findings, vulnerabilities, checklist findings, and then if you wanted to drill down, we could get back into that image and see all that. And then I guess one small plug, everything that you can do in Deep Security Smart Check is available through the API, and we published the API reference document here, and I'm actually going to pop a little link for that. So this document shows you how to use the API, and as I mentioned, everything that you can do with Smart Check you can do through the API. We've been building it API first. So that if you want to automate your business processes, you can do that using SmartCheck. And I think that's all I had to say. So I'm going to turn you back over to Kyle, and have a great day. Talk to you later. Bye.
Okay, thanks, Jeff. Okay, so we're going to go through a couple of questions that did come in. And just a reminder, or maybe you didn't know, but so Smart Check, we do a free trial available. So the links of interest are shown here on the slides. All this is available in the resources section as well, the slideware. Including my contact info is on one of the slides as well, so if you want to follow up on anything covered today or any of the questions we'll go through, you can reach out to me directly if you need to. Okay, so a couple of questions here. So one of the questions that came in is about on the runtime side, so Deep Security, which version of Deep Security has the advanced container security functionality? So we've actually been supporting container security since release 10. However, in the release 11.3 is where we added the local hooking for the container inspection. So anything 11.3 and up will support all of the features. The real-time anti-malware scanning and the IPS is supported as of release 10. So because we are adding a lot of container-related functionality, release over release, you'll see every release will have more container security content over time. So it's really, if you stay current, you're going to get more of the container protection. Okay, there's some questions about Smart Check and integration. So first of all, there's a question about if it's a separate product. So Smart Check is a Kubernetes application, so it is designed to be deployed as a standalone component or complement Deep Security. So if you're using Deep Security for runtime with Deep Security Manager and Deep Security Agents, or the SaaS variant, then it's designed to complement, but it's not a prerequisite to deploy Smart Check. So you can, if you just wanted to deploy Smart Check standalone for pipeline scanning, you do not need to deploy deep security as well. And another question about supported registries and pipeline tools. So we've developed the product to be pretty much agnostic of as many of the tool sets and services as possible. So we support pretty much all of the common registries. So all the cloud registries, the Docker registries, Quay, Harbor, Artifactory, and so on. So I think that pretty much covers all of the registries. Certainly all that customers have asked for, we support. As far as pipeline tools, Jeff's demo did show Jenkins. I did mention GitLab earlier, but basically using the APIs, as Jeff shown, we can pretty much integrate with any tool set just by using the APIs. And so, of course, that's an advantage in the architecture. There's no dependency on a particular pipeline tool, registry, or even cloud deployment platform. So you can deploy the security, and you can choose to evolve, switch, use multiple vendors, hybrid deployments, multi-cloud deployments, and so on. So we're perfectly compatible and designed, optimized for those type of deployments. Again, there's one question here. I'm going to pass it to Jeff. It's a question about when we scan the container, do we actually run the image to scan it?
Sure. So that's a really common question, actually, is whether or not we instantiate the image into a container and then actually scan the container that's running. There's a couple of reasons we don't do that, and there's a couple of reasons we don't. Mostly because if there's something in your container that's not good, so if your container has been compromised with malware or ransomware or anything like that, then we don't want to give that stuff any chance to execute at all. So what we do with SmartCheck is we will download the layers for your image, and we will scan through every single file in those layers individually. So we'll do the malware scan, the content scan, vulnerability scan, all that by downloading the layers and checking through the files individually. And we do that without starting the image, so without giving anything any chance to detonate.
Okay, great. So one more last question I think going to take here. There's a question about if there's a requirement for Kubernetes to deploy SmartCheck. So it is a Kubernetes application. So it is designed to be deployed as a Helm chart and requires Kubernetes. Okay. So I think that's it for the questions that have come in. If more come in, we can handle them directly after the webinar ends. The resource section does have a copy of these slides, and as I mentioned, there is a link to SmartCheck trial if you'd like to trial SmartCheck. And then also one of the slides does have my email contact information, so if there's some specifics that you might think of after the fact here, you can always reach out to me directly as a follow-up. So I'd like to thank everyone for joining today. I hope it was a good use of your time, and enjoy the rest of your day. Thanks.
Thank you.